All right, this is going to be a short video for two of the topics that we talked about with gas laws that we did in class, just in case you happen to be absent that day. So one of the things which will be on your test on Thursday, is converting pressure units. Now, hopefully you've got a periodic table nearby, so you can grab that and look at it, the reference table. So if we're converting pressure units, this is just a short factor label problem. Let's say we've got 475 kPa, and we need to convert that. So this is our known, and our unknown is how many atmospheres this is. So you're going to see on your periodic table, or no, sorry, not the periodic table, on the reference table, you're going to look for standard pressure. And you'll see a number of different units there. There's 1.00 ATM. And then another box, so these are all boxes. There's 101.3 kPa. There's 14.7 psi. And then there's 760 millimeters of mercury, or torr. So these units are all equal to each other. 1 atmosphere equals 101.3 kPa. 1 atmosphere equals 14.7 psi. And 1 atmosphere equals 760 millimeters of mercury. So when we're converting this, we're going to start like we always do with our known. Put it in the top of our table. If I have kPa on the top, I'm going to need kPa on the bottom. 101.3 kPa to 1, I'm getting my right here. These are equal to each other to 1.00 atmospheres. You're going to go ahead and put that in the calculator. And I'm going to use my fraction button like I always do. And it's going to be 475 times 1.00. Drop down in the bottom, 101.3 equals, that's going to give you 46. Going to need 3 significant figures, so 46.1 atmospheres. Oops, hang on. Let me back up. I just did the wrong, this is one thing when you should double check your numbers. So let's try that again. Fraction button, 475 times 1.00, drop down, and I typed the wrong number in, 101.3. And there's my answer. So that's going to be, let me just erase this. So my answer is going to be 4.69 atmospheres. And that would be my answer for this question. Let's try one more. Now let's go ahead and convert 6.75 atmospheres. That's my known. And my unknown is how many torr this is. So I'm going to convert this to torr. So again, I'm going to start with my known in the top of my table. If I have atmospheres on the top, I'm going to get atmospheres on the bottom. So 1.00 atmospheres is equal to 760 torr. And you'll notice that on your reference table, there is a decimal point there, so that is going to give you 3 significant figures. So let's put this one in the calculator, see if I can hit the numbers right. 6.75 times 760. Drop down the bottom, of course that'd be 1.00, equals, and that will be 5,130 torr. And I would have 3 significant figures with that, so my answer is good. So that's just converting pressures. And you've got all the pressure units you need to do that right on your reference table. Now let's talk about another one that we did in class. It was converting Again, this is going to be one using your reference table. If you look at the very bottom of your reference table, you've got Avogadro's number. And you'll see that there's a box there that says it's equal to 6.02 times 10 to the 23rd particles per 1 mole. There's another one that says the molar mass is equal to 1 mole. And then there's another one that says 22.4 liters is equal to 1 mole. Now, the liters is for a gas. This is true for a gas only. And this is also only true for a gas only at what's called STP, which is standard pressure and temperature. So STP, we could say standard temperature and pressure. That would probably be the right order to put this in. So this right here is only going to be true if it's at STP. And your gas law problem has to say the gas is at STP. So let's take a look at how this works. Let's say I've got 5.42 moles of a gas. And the gas is at STP, standard temperature and pressure. And the question says, how many liters would this be, or what is the volume? So we're going to do another factor label problem. We've got, oh my goodness, I cannot write today. Today's been a long day. 5.2 moles on the top of my table. If I have moles on the top, I'm going to need moles on the bottom. I want to convert this to liters. So 1 mole is going to go on the bottom. And then on the top is going to be 22.4 liters. I put that in the calculator, grab my calculator, not my phone, do the fraction button, 5.42 times 22.4 divided by 1, of course, equals, and you're going to get 121.408. My number had 3 significant figures, so my answer is going to be 121 liters. And that would be the answer to this question. Let's do one more here. Just bring this up a bit. And let's do one that's a little bit, well, let's do liters. Let's say that I have a gas, my known is my gas contains, 36 liters. And my unknown is how many moles that is, how many moles the gas will be. So I'm going to start with 36 liters of my gas. I have liters on the top, so I'm going to need liters on the bottom. 22.4 liters per 1 mole of gas at STP. So we'll put that in the calculator. 36 times 1, drop it down, 22.4 equals, and you're going to get 1.6 moles. So that's how many particles are going to be in that amount of gas. Now remember, this gas has to be at STP. Without it being at STP, this does not work. Let's do one that's just a little bit more complicated. And in this problem, we're going to start off with grams. Let's say I've got 36.2 grams of oxygen, O2. That's my known. And I want to know how many liters or how much volume, what is the volume this will take up. So I'm going to start with 36.2 grams of O2. I have grams of O2 in the top, so I'm going to need grams of O2 in the bottom. I'm going to grab my periodic table and look it up. I have 2 oxygen atoms. Each one of them weighs 16, so 32.00 grams of oxygen in 1 mole of oxygen. Now I'm ready for my next conversion factor. I'm going to liters, so 1 mole of my gas, of any gas, in this case it's oxygen, will take up 22.4 liters. So now I'm ready for my calculator. I've gotten to liters, my ending point. Fraction button, 36.2 times 1 times 22.4, drop down in the bottom, 32.00 times 1 equals. And that's going to be 25, let's see, I need 3 significant figures, so 25.3 liters of oxygen. So I can do these a number of ways. I could go say how many particles is this? We could go in lots of different directions, but these are just basic factor label problems. And the big thing is here is we're using this conversion factor in both of these problems. This will convert however many moles you have of a gas at STP into how many liters. And that's the short video.